Today we have a cool topic. It combines ideas from both computer science and math, and it's called PageRank. PageRank is perhaps one of the most famous algorithms by Google, and it's for sorting websites. Don't be confused. The page in PageRank doesn't stand for websites like I thought, and it actually is a name. It was created by Larry Page, who was a very smart man. If you haven't heard of him, he was actually one of the founders of Google. Now, when Larry created his company back in the day, he thought, the internet's growing and I need a way to connect people to the right information. So, this is how Google works now, but what he wanted was something where you could query keywords and it would return a list of all the different websites. But it orders them in a way that the ones at the top are most relevant. So we needed to think of a way of how to store these relevances, which websites are more important. In a library, they have what's called the Dewey Decimal System. But the key difference is the internet is messy and there's lots of information and it's not all good, it's not all published. So we needed to come up with an algorithm to sort it all. So what you can do is you can think of the internet as a graph with a bunch of points floating in space. We'll label all the websites A, B, C, D, E, F, and G, and one more, H. And these websites are all connected to each other. So we'll make C connect to A, these connect here. These are all front links. If you look at them, so C front links to A, and A has C as a backlink. Let's also make D connect to B. So the easiest way that we can rank these pages is with our most basic algorithm. We'll call it rank. Rank takes site as a parameter, and it's equal to the number of backlinks. So let's think about this for a minute. So A has one backlink from C, so it's a 1. B has one from D, so it's a 1. C has 3, one from E, F, and G. This one has 0, as well as this one, and this one, and this one, and F also has 1. The problem that we run into here is that the rank of A is equal to the rank of B. They're both 1, but if you look at it, the link coming from C is more powerful actually than D, because D doesn't have any links to it. So what we're going to do is we're going to change this algorithm around a little bit. And we'll make it so that our link is now the ancestors rank is added to the new one. So for all the zeros, they stay the same. But for H, it also stays the same because you're adding 0. But the first one where it changes is C. C becomes a 4 because it has F as an ancestor. So we'll change that one to 4. And A becomes 5 because C is now 4, and we're adding that. So that solves the problem there because A is now equal to 5, and the rank of B is still 1. So A is clearly more important than B, which you can visualize from our graph here.
Okay, so the internet is connecting to each other like spider web. We don't want to do but to count how many back page of each website. So we need to do it in a more mathematical way, a more efficient way. So now let's put it on a math mode. So let's say we have 4 pages. A, B, C, D, and they connected to each other. So A to B, B back to A to C, C to D, D back to B. And let's make it more complicated. And C goes to B also. And A goes to D. And D goes back to A. So they're supporting each other. And you can clearly see it from the graph. So now let's put it in math. In computer science, we can use matrices to rank different pages. So how to put it in matrix? That is a question, a trick question. So we need to list out all the backlink of each page first. So on page A, we got 3 backlink, 1, 2, and 3. Page B, we got 1. Yep, we only got 1 here. And do the same thing for page C and D. After we have all the backlink in a page, now we can set up our matrix. So if you got a 4 pages like this, you set up a 4 by 4. If you got an n pages, you set up an n by n matrix. So how to set up a matrix? Let's say A, B, C, D, A, B, C, D. Then page A does not support itself, so we put 0 here. So we got a support from page B, and page B is only 1 backlink. We put it 1 here, and we don't got any support from C, 0, and we got support from D. We put 1/2 because it's 2, so we need to divide by 2. Then for B, you do the same thing, supported by, you can clearly see from supported by A, and A have 3 outlinks, so only share 1/3 of the A, 0 on B because they don't support each other. Then 1/2, 1/2, do the same thing here. Okay, now we have the matrix, so what to do next? There's a equation called eigenvalue and eigenvector, so we can use that approach to rank the page. And how to do it, let me show you. Okay, this is a matrix. Then we set the eigenvalue to 1 because it should not be a negative number, because this is impossible to have a negative number when you're doing a page rank. So after we set the eigenvalue to 1, then the eigenvector you should get is 12, 9, 6, no, 4, 6. Should be right. That's correct. Then what's next is we need to scroll. So those are related to page A, B, C, and D. Those are the importance of each page here. Now we need to get the probability of each page. Then we add up those 4 numbers. 31, and then you got A is 12 over 31, B is 9 over 31, C is 4 over 31, and 6 over 31. And now you can tell A is most important because you got a probability, you got a probability of 0.387 here, and you got, for B, you got a 0.29, and for C, it's 129, and for D is 0.193. Then when you search something on Google, the first link on the page should be page A, because you can see those are the importance of each page. So that is the basic model, basic mathematic model to do the PageRank.
So to fix some of these issues with other models, we use something called the power iteration method. And what we do with this is we basically just take multiple iterations of the pages and their importance to each other, so that the important pages, their importance really shines through, and you can see if a page that maybe only has 1 or 2 links with something is shown as a weak website. So for the example, we'll do an example real quick with just 4 web pages. So we'll just call these A, B, C, and D. And these web pages, there's links between C and A. They both link to each other. A links to B, but B doesn't link to A. B links to D. C and D both link to each other. And C also links to B. So to set up a model to demonstrate the iterations of this, we'll just write them all out. And we'll call this first iteration iteration 0. And this is basically just used to initialize the problem and set everything up. And for this, we're just going to set the importance of these all equal to each other initially. So since we have 4 web pages, we're just going to do 1/4 as the value for each of these web pages. And after that, we can do our first real iteration. And to calculate the value for each of these, you simply take the value of the web page that links to it in the previous iteration, and then you divide that by how many websites that links to. So to give you an example for A, it has links from C. It only has a link to it from C. It doesn't have a link to it from anything else. So in the previous example, C is 1/4. So we take that. But C links to A, B, and D. It links to 3 different things. So we take this and we divide it by 3. And this comes out to 1/12. And so then we do the same thing for B. B has links from A and C. And so we know from the previous example that the value of C is going to be 1/4 over 3. And we're going to add the value of A as well, which is 1/4 as well. But A only links to 2 different things. So it's going to be 1/4 over 2. And this is going to come out to 2.5 over 12. And so then we can do the same thing for C and D, and the values are going to come out to 4.5 over 12 and 4 over 12. And we can just keep on going with this. I'll go for one more iteration to give you an idea of how it would play out. So in the second real iteration, we just do the same thing as we did in the past, except instead of using 1/4 as the value for all the web pages, we use the value that we calculated in the first iteration. So for A, its value is going to be, it only has a link from C. So in the previous one, C was 4.5 over 12. And again, C links to 3 different things. So we're going to divide that by 3. And this is going to come out to 1.5 over 12. If we do it for B, it's going to be C and A, the values for C and A. So C is, again, 4.5 over 12 over 3. And A is 1/12 over 2, since A links to 2 different things. And this comes out to be 2 over 12. If we do the same thing for C and D, we'll come out with 4.5 over 12 and 4 over 12, which happen to be the same exact numbers. So you can see the further you go, the less these numbers are going to change. And we don't necessarily care about the exact values of these numbers. All that we care about is being able to put them in order. Because when you search something into Google and you get a list of web pages, it doesn't give you the exact decimal value for how important it is. All it does is it just puts them in order of importance. So as long as we can order them, that's what we really want. So from this, we can just get our PageRank, which is just the importance of each of these. And we take the largest value as, the larger the PageRank, the more important it is. So C is the highest value, so it's 4, since we have 4 web pages. And then D is our next biggest one, so it'll be 3. B is 2, A is 1. So this means that C is the most important web page and A is the least important. So if you were to search up a term that would give you all these 4 web pages, you would get C, and then D, and then B, and then A, in that order as your results. And this is how Google does their page ranks. Obviously, they have way more websites than this, and they do more than 2 iterations, obviously. But this is the general way that they do it. Hope you like this video. If you like it, please like and subscribe, and check out our other videos.